Hi, hello friends, welcome to our channel Study of Mathematics. Next, we will go to the fourth problem in the solved problems 3.4.10. The problem is if omega is complex, complex means non-real cube root of 1, then show that determinant of 1 omega omega square omega square 1 omega square 1 omega is equal to 0. This is our given problem. In this problem we have to show that, and also we have to given omega is a cube root of complex number cube root of 1. Already we know omega is a cube root of 1, then we already know that 1 plus omega square value equal to 0. This is our one of the formula in a complex number. Then by using this formula we have to show this result. For that, first take solution. Write down the first LHS value. First write down the matter. Given that omega is complex cube root of 1, then we have 1 plus omega square is equal to 0. This is one of the result in a complex numbers chapter. Then by using that result we have to solve this solution. Then first take in the LHS value. LHS equal to determinant 1 omega square omega square 1 omega square 1 omega. Here we have to use one operation is that R1 is going to be R1 plus R2 plus R3. We have to take the operation is that R1 is going to be R1 plus R2 plus R3. Then LHS is equal to determinant R1 is going to be R1 plus R2 plus R3 means 1 plus omega square 1 plus omega square, and also omega plus omega square plus 1. Third value is omega square plus 1 plus omega. Remaining rows are same. Omega square 1 omega. Then that is equal to, already from the first equation, 1 plus omega square value is 0. Determinant 0. Here omega plus omega square plus 1 is nothing but this, that 0 plus 0. Omega square 1 omega square 1 omega. Already we know the properties of a determinant by using that. In that, one of the properties is that if all the elements of in any one row or one column are 0, then the determinant value is equal to 0. In this problem, the first row, all the elements are 0, equal to 0. Then by using that property, this determinant value is nothing but equal to 0. That is equal to RHS. Therefore, LHS equal to RHS. In this problem, two are the main points. That is, first is 1 plus omega square value equal to 0 is one of the most important point, and the other point is the one of the property is that in determinant that property is that if all the elements of in a row or a column are equal to 0, then the determinant value is equal to 0. By using that determinant property, we have to write down this determinant value is equal to 0. This is nothing but RHS. Then this problem solution is solved. LHS equal to RHS. Next we will go to fifth problem in the same solved problems. Next we will go to the fifth problem in the same solved problems 3.4.10. Then the problem is show that determinant a minus b minus c 2a 2a 2b b minus c b minus c minus a 2b 2c 2c c minus a minus b is equal to a plus b plus c whole cube. This is our given problem. In this problem we have to solve this. We have to show the result, that is solution. First taken the LHS value. LHS is equal to determinant a minus b minus c 2a 2a 2b b minus c minus a 2b 2c 2c c minus a minus b. This is our LHS value. In this we have to apply the operation is that R1 is going to be R1 plus R2 plus R3. The first operation is that R1 is going to be R1 plus R2 plus R3, that is equal to determinant first a minus b minus c plus 2b plus 2c. Then a value is nothing but a minus b plus 2b plus b minus c plus 2c plus c. In the same procedure, a plus b plus c, a plus b plus c. Then second row is same, 2b b minus c minus a 2b 2c 2c c minus a minus b, determinant. Then here in the first row we have to take a plus b plus c is common, then that is equal to a plus b plus c is taken common, determinant 1 1 1 2b b minus c minus a 2b 2c 2c c minus a minus b, determinant value. Here also we have to apply two more operations for columns. Then first C2 is going to be C2 minus C1 and C3 is going to be C3 minus C1. These are another two more operations that are then that is equal to a plus b plus c into determinant. For using here we have to use the column operations. Then first write down the C1 column has no operation, that is C1 column is same 1 2b 2c. For C2 column, C2 minus C1, that means 1 minus 1 0, b minus c minus a, b minus c minus a minus 2b, that means this value is minus a minus b minus c, because b minus c minus a minus 2b plus b minus 2b minus b, that is in write down in order minus a minus b plus by minus c. Here 2c minus 2c 0. From third column C3 minus C1 1 minus 1 0, 2b minus 2b 0, c minus a minus b minus 2c. Here also minus a minus b minus c. This is the value. Then here we have to take, that is equal to a plus b plus c into determinant 1 0 0, 2b here minus of a plus b plus c 0, 2c 0 minus of a plus b plus c. This is the values. Here we have to take in second column we have to take a plus b plus c as common, and third column, from third column we have to take a plus b plus c as common. Then the remaining values are, then here taking common a plus b plus c, here a plus b plus c into a plus b plus c, here whole cube. The remaining value determinant 1 0 0, 2b, here remaining value minus 1, 0, 2c, 0, minus 1. Then that is equal to a plus b plus c whole cube into the splitting the determinant value, then 1 into minus 1 into 1, 1 minus 0. Minus 0 into, here this is column 0, minus 2b minus 0 plus 0 into 0 plus 2c. That is equal to a plus b plus c whole cube into 1 minus 0, here minus 0 plus 0. That is 1 into 1, 1. 1 into 0, minus 0. 0 into anything value is 0, minus 0, plus 0 into anything value is 0. That is equal to a plus b plus c whole cube into 1 is equal to a plus b plus c whole cube. That is the RHS of the given problem. Then therefore LHS equal to RHS. This is the solution of the fifth problem in the solved problems 3.4.10.
Thanks for watching our video. For more videos, please like, share, subscribe to our channel and hit the bell icon.